Yeah, this next question is, pretty big, pretty general, but if you had to explain to the general audience, right, how quantum mechanics really reshaped our understanding of the universe, what would you say?
That's deep.
So, yeah, I mean, you guys know I'm hesitating because that's a big question for me, and I've been
Hmm.
talking to
For
both of
sure.
you about it for most of the term.
Mhm.
And there are different ways to look at it, but yeah, I would say that unlike most physical theories that just say, oh, things don't really behave the way you thought, they actually all fall at the same rate, or stars are actually other suns, or things like that. To understand quantum mechanics, you end up having to change your view of what it means to picture the real world, what a description of reality would be. And not just, as people often say, descriptions of really small things or atoms or electrons, but of everything. There's just no way to make the quantum mechanical theory of atoms consistent
Hmm.
with a kind of more classical, Aristotelian or Newtonian or whatever view of rocks and planets and you and me. And I really think that's different from, learning, hey, what do you know? Light is made of electric and magnetic fields. That really changed how we thought about light, but it didn't change how we thought about anything else. How I think about me and you or, water waves or anything. Um, so to me, there's something more deeply philosophical about what we learn from quantum mechanics.
Hmm.
And how to best put it? I guess the most popularized aspects of it are not 100% accurate. One of them is randomness, and although again I've discussed with you guys the subtleties of that, we don't have any proof that the world is random. The most natural way to look at the theory of quantum mechanics does make it look like there's randomness fundamental to the laws of physics. And
Hmm.
that's certainly a big change. And even if you don't take that interpretation and try to look at it differently, there's something in there that changes. That things I used to describe definitely, the moon is definitely there, the Earth is definitely here. Quantum mechanics says you can't really describe things like that. If nothing else, particles are described by wave functions, which means that they have uncertainty. And I think from the modern viewpoint, especially driven by everything we've learned from quantum information, that would be one of the big things to say, that the information about the world is a different thing according to quantum mechanics than you would have thought according to our classical intuitions. And the most complete description that we think is possible of things in the world is still a description that leaves some uncertainty. And that's pretty striking. And that's the kind of thing I was alluding to before. How could you know such a thing? How could you ever know that your description is incomplete, right? It's one thing to
Hmm.
say, I don't have all the information. It's another to say, it's impossible to have all the information. And more people think that's what quantum mechanics teaches us. And again, that's not something that can be proved, but even if you sidestep it, it deeply changes the way you have to think about reality.
Hmm.
So the way I always explain it is that classically, there's some way of describing the state of a system. You look at a pool table and you see where all the billiard balls are, and I just tell you where is each ball, how fast is it moving. That's a complete description of what's going on. And to me, what quantum mechanics has taught us is that the description of any system involves making a list of every possible kind of classical state it could have and saying every one of those has a kind of weight to it, something like a probability. And to describe what the world is doing, I need to give you that whole list of weights for all the things that could be happening,
Hmm.
tell you how likely they are to be happening.
Hmm.
And again, as you know, on the technical side, how likely isn't sufficient. But to the layperson, I'd say that kind of gets the idea across. You don't say the cat's alive or dead. You say how likely is it to be alive? How likely is it to be dead? And that's the right description of what the cat is doing.